Hello students, in this section we will discuss the different units for measuring distances, and first and foremost we are going to discuss the units which are very large in size and basically used for measuring astronomical distances, right? So let's start with light year. In the first appearance, it might appear to you as if it is the unit of time, but actually light year is the unit of distance. It is the distance covered by light in air or vacuum in one complete year. So let's try to find out the relationship between light year and the SI unit of distance, which is meter. So let's find out the relationship. We are aware of this formula: distance is equal to speed multiplied by time. Look, light year, as per the definition, it is the distance covered by light in air or vacuum during the interval of 1 year, right? In air or vacuum, the light travels with speed of c, which is 3 into 10 raised to power 8 meter per second. So let's substitute the value over here. 3 into 10 raised to power 8 meter per second. This is the speed of light in air or vacuum. And what will be the time interval considered? It is equal to 1 year, 365.25 days. Let's assume 365. So it has to be converted in seconds. So 365 days. Each day is equivalent to 24 hours. Each hour is equivalent to 60 minutes, and each minute is equivalent to 60 seconds. So this will be in seconds. This will be in seconds, right? So this is the total time interval, that is of 1 year, and it is given to be in seconds. So light year is the distance. It is the distance covered by light in air or vacuum during the time interval of 1 complete year, right? If you evaluate it, you will get the numerical value in meter. Second per second get cancelled, you will get meter. So its value is found to be 9.46 into 10 raised to power 15 meters. So you can easily evaluate this and you can get this relationship. So this is a very important one. Please do remember this. Light year is the distance traversed by light in air or vacuum during 1 complete year. And 1 light year is equal to 9.46 into 10 raised to power 15 meters. So you can see 10 raised to power 15 is very high order. So light year is a very large unit, right? There are some other big units as well for measuring astronomical distances. We'll discuss the second one. So it is astronomical unit. It is astronomical unit. It is represented by AU. It is another large unit for measuring distances. Actually, astronomical unit is the mean distance of the sun from the earth. It is the mean distance of the sun from the earth, right? So later on we will discuss several indirect methods in which we can easily calculate the distance of large heavenly bodies or large or distant objects from the earth's surface. So the distance of the sun from the earth is found to be 1.496 into 10 raised to power 11 meters, and that is known as astronomical unit. So astronomical unit is represented by AU, and it is defined as the mean distance of the sun from the earth, and its value is experimentally found to be 1.496 into 10 raised to power 11 meters. So again, this is a very important relationship which a science student must be aware of, right? There is another huge unit that is known as parallactic second. It is parallactic second. It is known as Parsec. Parallactic second. Again, second, it might appear as if it's the unit of time, but do remember it's a unit of distance. It's a huge unit for measuring large astronomical distances. Let's define this parsec, right? Now, in order to define this, let me give you a simple illustration. This is, suppose, a circle. This is the center, and let us consider an arc AB. Let us consider the length of this arc AB is 1 astronomical unit. Just now we have discussed astronomical unit. So let's imagine the length of this arc is 1 astronomical unit, and this arc subtends an angle of 1 second at its center. This is the symbol for second. So let us consider an arc of length 1 AU which subtends an angle of 1 second. This is 1 second at its center. In that case, this distance from center to A or center to point B, this distance is known as parsec. This will obviously be the radius. This is the length of the arc, isn't it? And this angle theta. Clear? So, angle we are aware, it's given by length of the arc divided by radius. This is the formula. So, we will make use of this basic formula to determine the relationship between parsec and meter. Right? Before that, let's come across the definition. Now, I am sure you will be able to appreciate the definition, or rather, you will be able to remember how to define parsec logically. Parsec is this distance, right? This is the distance, which is parsec. Now look, parsec may be defined as the distance at which an arc of length 1 AU subtends an angle of 1 second at its center, right? So parsec is the distance at which an arc of length 1 AU subtends an angle of 1 second. Clear? This is how parsec may be defined. Now let's evaluate its value in meters, right? We are aware of this particular formula. Angle theta is equal to length of the arc divided by radius. We need to find this r, radius, which is 1 parsec. So r would be equal to L by theta. Fine. Now, r, it is 1 parsec. It is equal to length of the arc, that is 1 astronomical unit, divided by this angle theta, which is 1 second. This is 1 second. Now I need to determine the relationship between parsec and the SI unit of distance, which is meter. So I need to convert it in SI. So I need to express astronomical unit in meters, as well as I need to express 1 second in radian. Remember that the SI unit of angle is radian. So basically, in sexagesimal system, 180 degree is considered to be pi radian. So 1 degree would be equal to pi by 180 radian. 1 degree is equivalent to 60 minutes, and 1 minute is equivalent to 60 seconds. So 60 minutes, it's written like this. It is pi by 180 radian. Therefore, 1 minute would be equal to pi by 180 into 60 radian. Right? And as I told you, in sexagesimal system, 1 minute is equal to 60 seconds. It is pi by 180 into 60 radian. Therefore, 1 second is equal to pi by 180 into 60 radian. This is again a very, very important relationship. So, you can substitute this value second over here. You can write AU in terms of meters. In that way, we can easily determine the value of parsec, right? So let's solve it. Therefore, 1 parsec, it will be equal to 1 AU. It is 1.496 into 10 to the 11 divided by this much. 1 second is pi over 180 into 60 into 60. If you solve it, you will get 3.08 into 10 raised to power 26, 10 raised to power 16 actually. 3.08 into 10 raised to power 16 meters. This is the relationship between parsec and meter. 1 parsec is 3.08 into 10 raised to power 16 meters, right? Let us discuss these 3 topics again, and then we'll try to find out the relationship between parsec and light year. And then we'll also discuss some other units as well. So, what we have discussed was, we have discussed 3 large units for measuring distances. First, we have discussed light year. Light year, students, it's defined as the distance travelled by the light in air or vacuum during one complete year. And we have discussed 1 light year is equal to 9.46 into 10 raised to power 15 meters. Second, we have discussed astronomical unit, right? Astronomical unit is the mean distance of the sun from the earth, and that is experimentally found to be 1.496 into 10 raised to power 11 meters. And lastly, we have discussed parsec. It stands for parallactic second. It is the distance at which an arc of length 1 astronomical unit subtends an angle of 1 second at its center, right? And 1 parsec is equal to 3.08 into 10 raised to power 16 meters. So out of light year, astronomical unit and parsec is the bigger unit. So can you find out the relationship between parsec and light year? Let's do it. 1 parsec, just now we have verified, it is 3.08 into 10 raised to power 16 meters. 1 light year, it is 9.46 into 10 raised to power 15 meters. So if you divide these two, 1 parsec divided by 1 light year, it will be 3.08 into 10 raised to power 16 divided by 9.46 into 10 raised to power 15. So 10 raised to power 16, when it goes towards the numerator, it will become 10 raised to minus 15. So we will be left with 30.8 divided by 9.46. So that is about 3.26. So we have come across a very important result, which is 1 parsec, 1 parallactic second is equal to 3.26 light years. Students, this is a very important relationship, right? 1 parsec is equal to 3.26 light years. So these were the units for measuring large distances. There are some other units for measuring distance as well. Kilometer, 1 kilometer is 1000 meter, right? Foot, centimeter. These all are the units for measuring distances. There are some other units which measure extremely small distances. I am talking about atomic distances. In such a scenario, we make use of Angstrom or Fermi. The size of an atom is of the order of Angstrom. So, these are the units of distances which are used for measuring atomic, that is very small distances. So, Angstrom. Angstrom. It can be written as like this. It is 10 raised to the minus 10 meter. Remember AU, capital AU, it stands for astronomical unit, and this capital A, it stands for Angstrom. It is actually the order of the size of an atom, 10 raised to minus 10 meter. Then Fermi, it is 10 raised to minus 15 meter, right? So these are the units which we will be using while measuring extremely